In question 2 of this series, we're asked, find the first quadrant length of the curve y is equal to x to the power of 3 over 2 from x is equal to 0 to x is equal to 4. A graphical representation of this function is shown right here. And to do this problem, we have to use the following formula, the arc length formula. Let's go ahead and set it up. S, which represents the length, is equal to the integral between our lower and upper bound, 0 and 4. For the integrand, the square root of 1 plus the derivative of our function to the power of 2 dx. So I'll leave this part blank and I'm going to work on the derivative. The derivative of x to the power of 3 over 2, I'll call this y, is the following. And we'll do this implicitly. Y becomes dy over dx. And this part we'll use the power rule, where we take 3 over 2, bring it at the front, 3 over 2, x to the power of 3 over 2 minus 1. 3 over 2 minus 1 is half. So I'll replace this with 1 over 2, giving us the following. 3 times x to the power of 1 over 2, or 3 times the square root of x over 2. I'll take this now and place it right here. And remember, the derivative is powered by 2. Take a look at the formula. So if we square the numerator and the denominator, here's what we end up with. This 2 gets distributed to the 3, to the x to the power of half, and the 2, giving us s is equal to the integral between 0 and 4, the square root of 1 plus 9x over 4 dx. Let's integrate this. We can set this equal to u and take the derivative of u. U is equal to 9x over 4 plus 1. I just rearranged it. Now taking the derivative implicitly, we get du is equal to 9x over 4 becomes 9 over 4 dx. Solving for dx, we get dx is equal to 4 du over 9. I'll now replace dx with 4 du over 9, and here's what happens. We get s is equal to the integral between 0 and 4 once again, the square root of u, 4 over 9 du. Bring this 4 over 9 outside. We don't need to integrate that. 4 over 9, and the integral of the square root of u. The integral of the square root of u is the following. U to the power of half, we add 1 and divide the sum of this, which is 3 over 2. This ends up becoming 2 u to the power of 3 over 2 over 3. That's the integral of this function. And of course I will replace u back with what I set it to, giving us 4 over 9 square bracket 9x over 4 plus 1 to the power of 3 over 2 times 2 over 3. Now I have to find out what this is at x is equal to 4 and what this is at x is equal to 0. I find the answers for both and subtract the upper bound from the lower bound. Now, before we evaluate this at x is equal to 4 and x is equal to 0, you see this 2 over 3? I'm going to pull out that 2 over 3 so that it's multiplied to 4 over 9. That will make our calculation a little easier on us. So 4 over 9 times 2 over 3 times 9x over 4 plus 1 to the power of 3 over 2. And so we'll only evaluate this part at 4 and 0. Let's start at 4. 9 times 4 over 4 is 9. 9 plus 1 is 10. 10 to the power of 3 over 2. This part becomes 8 over 27. Minus, now inputting 0 into here, this becomes 0. 0 plus 1 is 1. 1 to the power of anything is 1. Let's use our calculator and do this all in one shot. 8 over 27 times 10 to the power of 1.5, which is equivalent to 3 over 2, minus 1. This gives us a length of 9.07. There you have it. That is how to set up and find the arc length of a function.